Bismillah ar-Rahman ar-Rahim. Assalamu alaikum. This is Dr. Ahmad Al Faris. Last time we was talking about reflection of light as wave, electromagnetic, and transverse wave. Now we talk about the reflection and the law of reflection. Okay. Then we talk about the characteristic of the image. Okay. Now we're going to answer the multiple choice question that was your homework. Okay. First question, question number 1. What's the answer? If you please send me the answer. شكرا يا إبراهيم. شكرا يا Sandra. Yes, who else? Send me the answer. Anyone else? يلا. شكرا يا عبد الرحمن. Okay. Now let's read the question. What they said. The diagram shows the image of a clock in a plane mirror. Okay. شكرا يا محمد. What time is shown? يعني I'm seeing this image from a reflection of a mirror. So that means we have the two hands. This hand, it will be in this direction if this is the mirror. Okay. And this will be on this side. So how much is the time? It's 9:25. It's 9:25. This is between 9 and 10. It's 9. And this is how much? 25. So the answer is C. Okay. It's obvious that 2:35. So, okay, but it's not the reflection of the mirror. They say that it's a reflection of a mirror. Bring your ruler or your calculator and see the reflection of this clock from the ruler or from any smooth flat surface. You can see that it will be 9:25. Okay, so the answer is what? The answer is C. Yes.
Can I bring a mirror to the exam?
You can bring your ruler. You can bring your ruler. You can use the same math set box. Okay, it is metal shiny surface. You can use it as a mirror. Yes.
But okay. Can I use an actual one?
I don't know if they're allowed to bring it or not. No problem. Bring it. How many questions they will bring about this? No problem. Okay. Yes. Now, question number 2. A plane mirror is on the wall. Which is correct descriptions of the image found by the mirror? Yes, send me the answer. Yes, شكرا يا سلمى. Who else? شكرا يا إبراهيم. Anyone else? شكرا يا أدهم. شكرا يا محمد. Also. Okay, Hazem, thank you. Good, correct. So is it a right way up smaller? No, it's not a smaller. Is it right way up? Okay, and same size? Yes, it is. Is it upside down? No, it's not upside down. So the answer is what? Is B. Okay, correct. All of you answer correct answer. Okay. Number 3. A ray of light strike a mirror, okay, at an angle of incident of how much? 60 degrees. This is the angle of incident. Okay, the reflection of the mirror, okay, then strikes to a second plane mirror, okay, with an angle of how much? 45 between the both mirrors. Okay, the angle of reflection or the angle of incident on the second mirror is how much? Now, as you can see, we have 5 options. This is not an IGCSE question. Okay, I bring it from another board. Okay. And we have to try to draw it. So we have these two mirrors. The angle between these two mirrors is 45 degrees. Okay. And now we have an incident ray, okay, with an angle of how much? 60 degrees. This is the normal. Okay. It will reflect with an angle of reflection also. What? 60 degrees. And it will hit the other surface, the second surface. Now this is the normal, as you know. So since, okay, yes, I forget my hand is not straight line. I'm trying to draw it as a straight line as possible. Okay. Now, since this angle is 60, that means this angle left is what? 30. Can you see this triangle, this big triangle? Okay, with 45 and 80. How much left here? How much is the whole angle left here?
105.
Exactly, 105. And they ask about what? about the angle of what? Incidence, or the angle of what? Of reflection in this direction here. How much it left after 105? I subtract
90.
90
No,
from it, exactly. It will be how much? 15
15.
degrees. Why I subtract 90? Because I want to find this angle with the normal, not with the surface. The whole angle with the red color here, it's 105 with the right, with a big triangle. Okay, because this is 30, this is 45, 75, 180 minus 75, which is 105, 105, minus 90 degrees, so it will be 15 degrees. So the angle of reflection or the angle of incidence here, both of them, they will be what? 15 degrees. So the answer is what? Is A. شكرا. Yes, شكرا إبراهيم. شكرا للشباب اللي جاوبونا. Okay, الصبايا. This is a hard one, okay? Next, what do we have? We have 3 questions, 4, 5, 6. They ask about the same idea. X and Y of each 2 meter tall. Okay, X is 1 meter, okay, away from a plane mirror. Y is 2 meters away from the same what? Mirror. Now, this is the, okay, look here. This is the mirror. This is our mirror. And we have 2 objects. We have object X somewhere here, 1 meter away. So this is the image of it. Okay, and we have what? Object Y, 2 meter away. So this is the reflection of it. Okay, what do they ask? Let's do the questions. Question number what? 4. Okay, the size of X's image compared to Y's image is, yeah, send me the answer. شكرا أدهم, شكرا محمد, شكرا Sandra, Ibrahim. Anyone else? Okay, because they ask about compare the size of the image, and we are talking about the plane mirror, and both of them, they are 2 meter tall. So the answer is C. Their images, it will be the same height. Shukra ya Salma, yes, same height. Why same height? Because their image, it will be the same as their height. So since this height is 2 meters, the image of it will be 2 meters, and the same thing for object Y. So both of them, they have the same what? Size. That's question number 4. Question number 5, it seems, as I said last time, it seems to X that's Y's image, okay, as compared to its own. Now look here, this is X. Look to his own image and look to Y's image that looks behind him, because it's farther, okay? It seems that, which one is the answer? Shukran Salma, Shukran Muhammad, Shukran Ibrahim, okay? It seems because they are farther. It seems, yes, it is smaller. Bravo. Okay, it seems that it's smaller because it looks farther, but we don't know how much the height of it unless we compare it with math and trigonometry and physics formulas. Okay, that's question number 4. Question number 6, the distance between X images and Y's image. This distance, how far it is? Yes, who can tell me how far is this image? Yes, Shukran Adham, Shukran Ibrahim, who else? Shukran Muhammad. Yes, bravo, good. The distance, because we know that this distance is 1 meter and this distance is 2 meters. So how far they are here? It's 1 meter, so the same as their images. So the distance, it's 1 meter. The distance between X image and Y image is 1 meter. Tamam. This is from the old syllabus of SAT, the American system. Okay. Tamam. Next, question number 7. Let's return back to our board, the IGCSE Cambridge. What do they ask here? In the light wave, send me the answer. Yeah. Send me the answer that you did it in the homework. Ibrahim, Muhammad, yes. Abdul Rahman. Yes, but all of you are correct. Okay. What is the answer? The answer is A. What's the answer? The answer is A. I'm going back here because some of you asked me to go back. You can take a screenshot if you want. These are the answer for question. You are welcome. 3, 4, 5. So question number 7, the answer is A. Both electric and magnetic fields, they vibrate in transverse way, perpendicular. Okay. Question number 8, it's obvious. We will use the formula. What do we have? We have the wavelength, and they ask about the frequency. And we have to know that the speed of light and air is this value. So which one is the answer? شكرا يا محمد. Who else? يلا في ناس من زمان ما شاركوا. في ناس من زمان ما سمعنا لهم صوت. Okay, you will use the formula V equal F lambda. So F equal V over lambda. Okay, which is 3 times 10 to the power of 8 over the wavelength, which is 1.5 times 10 to the power of -7. And the answer will be 2 times 10 to the power of 15. And it will be what? Exactly, it will be A. شكرا يا إبراهيم ويا أدهم الشباب اللي شاركوا. Next. Okay. I just want to tell you that. Okay. ما شاء الله. شكرا لك. شكرا ما شاء الله. Good marks. Okay. Now that's question number 8. Question number 7. She told me her mark. Okay. How much she get in the final exam in physics. ما شاء الله. Okay. Number 9. Which of the following, okay, has the shortest wavelength? Which one has the shortest wavelength? I told you that you have to memorize them in order, okay? As I think Ilaf or Salma sent us a word that we have to memorize them in order, okay? Now we have gamma rays, X-rays, okay? Then what? Yes, we have gamma rays, X-rays, ultraviolet, visible light. Then what? Infrared, microwave, radio wave, or you can say it vice versa. Okay, and they ask about what? Which one has the shortest wavelength? The shortest wavelength that has greatest frequency. Yes, correct يا إبراهيم يا محمد ويا حازم. في ناس بعتوا بس لحقتش أقرأ أسمائهم. And the answer is what? Is C. Yes, gamma rays has the shortest wavelength. Now, number 10, what do they ask here? Number 10. The diagram shows a section of electromagnetic spectrum. Okay, how do the frequency, okay, and the speed of gamma rays compare to the visible light? Now the speed, which one is faster? Yes, give me the answer. Yes, exactly, the answer is A, because they have same speed in vacuum, but gamma has greater what? Frequency, so the answer is A. Bravo. Next. Question number 11. So the answer here was C. For number 9, for number 10, it's A. Number 11, what they ask. A piece of paper has PAL, okay, written on it. A student hold the paper in front of what? A mirror, PAL from Palestine, okay? What does the student see? Which one is the answer? شكرا يا محمد, شكرا يا إبراهيم. Who else? Okay, شكرا يا محمد again. You will have several Muhammad here. Okay, Abdurrahman, yes. Yes, exactly. You see them laterally inverted. Okay, not upside down, inverted. So the answer cannot be, okay, D or C. It will be what? B, exactly. You use your phone. Excellent. Some of you can use the ruler, others can use their phone, what to see the reflection of the screen itself, to see how it looks like. Yes, bravo. Question number 12. A girl wrote the word left on a piece of card like this. Okay, she looks at the image of this card made by the reflection of a plane mirror. What does she see? Yes, which one is the answer? Shukran ya Abdurrahman. Yes, who else? Yalla. Send me the answer. I only use my brain. Bravo عليك. Okay, so the answer, shukran Ibrahim, shukran Muhammad, shukran Salma. Okay, the answer is what? Number 10, I think the answer is A. Number 11, it's B. And number 12 also, the answer is what? Is B. Yes, shukran ya Ali. Okay. So far they are easy questions. Okay, there is no tricks in these type of questions. Question 13. a ray of light strikes in a plane mirror and it's reflected. Okay, this is the incident ray, as you can see here, and it reflects in this direction. Good. Okay, which pair of angle must be equal? The word must be equal, that means there is a law to control this, and the answer is yes. Shukran Muhammad, shukran Layth. Who else? Tamam, send me the answer. Good. Excellent. Shukran Ibrahim also. Okay, the answer is C. The angle of incidence must be equal the angle of what? Of reflection. So the angles X and Y, they have to be what? Equal. Good. Shukran alaykum. And we did a few questions here. Question 3, 4, and I think 5. Then we reach this question and we did it, we draw it. Okay, then we start talking about what? Refraction of light. And refraction, we said it's the change in what? In the wave direction between two different media due to the change in what? In the speed. Okay. Okay. Due to the change in the speed, and that we use the 6 S's I told you about. In shallow water, the speed is slow, the wavelength is short, the angle is small, and the frequency remains the same, but the direction bends towards the normal. Okay, and we draw how the light changes direction as travel from medium to another. The angle depends on something called refractive index, and we said in refractive index is the ratio of speed of light in vacuum to its speed through the medium, and we say the famous word in French, the refractive index equal what, ya shabab? Yes. It's a famous song. C over V, but what we say it?
C de la vie.
C'est la vie, yes. T is the silent in French. C'est la vie, exactly. Okay? C'est la vie. So, and also we know that the refractive index equals sine I over sine R. Okay, sine I is the angle of incidence over sine R is the angle of refraction. But I prefer another formula that sometimes it's useful to use it, because here this formula n equals sine I over sine R, only I can use it when the light travels from fast region to where? To what? To slow region, and that makes sure that I is greater than what? R. So that's how we use this formula, but I prefer that we have to use the original formula for Snell's formula. What this is? N, refractive index of the medium I, okay, sine I, the refractive index, equal N, the refractive index for the refracted media, okay, and R, what? Sine R, the angle of what? Refraction. This formula I prefer from you to use it, okay, because it's much easier when they make the question change from slow medium to fast medium, the opposite. It will be harder, okay? You can use it in both ways, from slow to fast or fast to slow, but this one, the first one that's written in the syllabus, refractive index equals sine I over sine R, we usually use it from slow to fast. If they change it from fast to slow, if they change it from slow to fast, okay, I'll switch the position of I and R to make the angle on the top greater than the angle in the bottom, unless they give us that the refractive index here, it's less than 1. It's supposed to be more than 1. So the refractive index in this type of questions, it's supposed to be more than 1 to use this formula, okay? Good so far? Take a screenshot for these informations, and let's do question number 2 here after it. Yalla. Okay. Any question number 2, what they ask, okay? Calculate the refractive index of what? Of light passing from air to water, air to glass, water to glass. Now, I can't answer these questions unless I know how much is the speed or how much is the refractive index. Or how much is the angles, I'm sorry, or how much is the angle. But here they give us how much the speed for each medium, the speed in air, the speed in water, and the speed through the glass. And as we know that the speed in air or in vacuum is the fastest, 3 × 10⁸. Speed in water, it will be a little bit slower, 2.3 times 10 to the power of 8, and speed of speed of light in the glass, it's 2 times 10 to the power of 8, etc. Now, what do I need to find? I need to find first part, okay, to find the refractive index. From where to where? From air to water. That means I will do C of air over V of water. Okay, C is the speed of light in air or vacuum, which is what? 3 times 10 to the power of 8, divided by V in water, which is 2.5 times 10 to the power of what? Of 8. And by using the calculator, the answer is, how much is the answer? It will be approximately 1 point something, 1.5. Okay, 3 divided by 2.3. Yes, 1.3. I'm sorry, 1.3. 1.3. Okay, this is the refractive index for whom? For the water, or for the light travel from air into water. That means it slows down by how much? By 1.3 times. Okay, is there a unit here for refractive index? No, there's no unit for refractive index. Why? Because it's a ratio. Okay, that's for part A. For part B, what do they ask? From air to glass. That means they ask about the refractive index of the glass. From air into the glass, that means I will use the same formula, C over V, c'est la V, over or for what? For the glass, which is 3 times 10 to the power of 8 over 2 times 10 to the power of 8. Shukran ya Ibrahim. By using calculator, the answer will be 1.5. This is the refractive index for the glass, or for the light traveling from air into glass for this situation. Good so far? Okay. Now, rarely they ask questions like, not air is not included or vacuum is not included. Like from water to a glass, or from glass to water, or other different materials that air, none of them. Okay. They rarely bring questions about that. So what I'm going to do now, I'm going to answer this part C. The refractive index from what? Water to glass. That means I'm dividing the speed of what? Exactly, of water, divided by the speed of what? Of the glass, exactly. So like, as you can see, from air to glass, we put air over glass. From air to water, we put speed of light in air over speed of light on water. So I will use the values here, which is what? 2.3 times 10 to the power of 8, divided by the speed on the glass, which is 2 times 10 to the power of 8. And the answer will be how much? 1.15. I can be smart. I can be smart and say that the refractive index from water to glass, it's equal the refractive index of glass over the refractive index of what? Of water. How did I reach this formula? I divide this, okay, from this equation, and I use this from the other equation, part B, and I put them together, and that's what I get, okay? Make a subject of the formula, but not, it doesn't matter, okay? So you can use the original formula or what? This new formula, okay? And it's not necessary to use it, okay? Which is how much? 1.5 divided by 1.3, okay? 1.5 divided by 1.3, these values, okay? And the answer will be the same answer, 1.15, okay? Tamam? Good. Write these down if you please. Shukran, Ibrahim. Okay, send me write these answers if you please. Okay. Ya Allah.
Mr. I didn't understand.
Which one? A or B or C?
A.
A? Why? Why A?
It's a little complicated.
Okay, from beginning. Refractive index, always it's C over V. What do I mean by C over V? Okay, that means the light travel from the air, okay, to the medium, whatever the medium it is. So C is the speed of light in air, okay, divided by V, which is the speed of light aware of the medium, okay, whatever the medium it is. Okay, it can be air, it can be water, glass, diamond, whatever, oil, whatever it is. Okay, so what I'm going to say, refractive index of the light traveling from air to water, it's C over V, C la V, okay, which is 3 times 10 to the power of 8 over the velocity that they give it to you for the water. And the same thing you repeat it in part B or part C. This one, this is a new thing. This is a new thing, okay? But this is the original formula. Okay, C over V or V of air over V of the medium that they ask about it. Good?
Okay, thank you.
You are welcome. You are welcome. That's question number 3. Question number 4. What this is? A ray of light enters a pond at 30 degrees to the horizontal. What is the direction, okay, as it travels through the water? How much is the angle of refraction, or how does it change its direction? Okay, now we have a water pond. Okay, this is the water pond. So we have air here, okay, and above we have air, and there is water below. And they didn't mention here, but they have to give us that the refractive index of water is how much? 1.3 or 1.33, something like this. They have to give it to you in the question. I did write it down. Now, what they said that this ray enters horizontally with an angle of how much? 30. So this is the incident ray. And the angle with the horizontal is what? Is 30. What we can call this angle, the 30 degrees, what we can call it, this angle between the ray and the surface. Can we call it anything here? No, we can't. No, of course we can't. So, yes. Why? Because it's not our angle of incidence. We have to draw what? We have to draw something called what? Yes, the normal. Bravo. And this angle between the ray and the normal is the angle of how much is incidence. How much is the angle of incidence in this situation? Yes. How much is it? Exactly. It's what? 90 minus 30, which is what? 60. Now, in this situation, does the light bend away or towards the normal, since it travels from air to water? Towards the normal. Why towards the normal? Bravo, because it slows down. So this will be our direction like this. And this is the angle of refraction that we want to find it out. Okay, so what I told you that I'm going to use the formula, the long formula, Ni sine I equal what? Nr what? Sine what? R. Ni is the refractive index for the first medium. How much is the refractive index for the air or for vacuum? We assume it's 1. Okay, multiplied by sine. How much is the angle of incidence here? It's 60. Why is 60? Because it's not 30, it's 90 normal minus 30. Okay, good. Equal. How much is the refractive index for the refractive medium? It's the water, 1.33 multiplied by what? Sine what? R. I need to find R. So over 1.33 over 1.33. Okay, then sine inverse. So R equal sine inverse of sine 60 over 1.33. And by using calculator, how much is the answer? It will be, where is it? If you have a calculator, you can give me the answer. It's approximately 40, 30, something like this. Okay, sine inverse 4 sine 60 divided by 1.33. Yes, it's 40.6. 40.6 degrees. You can write 41 degrees. Good. So again, in this question, the trick was that they give us the angle which is 30, which is not the angle of incidence. Okay, it's the angle with the surface. So I have to find the angle of incidence. Then I have to imagine. So that's why I sketch here to find this. Okay. Yes, Leith, go on. Further.
Sir, I'm sorry, but I couldn't hear you when you explained the question.
No problem.
The voice is cut off.
I will re-explain it. No problem. Okay. Question number 3 again. A ray of light enters a pond. Okay, at 30 degrees to the horizontal. This is the water pond. There is water in the bottom and air above it. Okay. at an angle 30 degrees to the horizontal. This is the horizontal, this is the angle of incident, this is the incident ray, 30 degrees. Okay, but the angle of incident with the normal. So the angle of incidence, I, it's equal how much? 90 minus what? 30, which is what? Which is 60 degrees. Okay, this one. So we'll use the long formula, or you can use the short formula. Okay, definition formula, that's N equal what? Sine I over what? Sine R. So how much N the refractive index for the water? It's 1.33 equal sine 60 over sine R. Then we do cross multiplication and we find R equal sine inverse for how much? For sine is 60 over 1.33. And by using calculator, the answer will be how much? 40.6 or 41 degrees. Is it clear? Did you understand it, Laith?
Yes, sir, but can I just ask, where did we get the 1.3 from?
They give it to us in the exam. This is the value. I wrote it now in the after the question. Every time they have to give it to you in the exam. Yes. If they don't give it to you, they have to give you another information. Okay? Tamam, tamam. Now, so in general, ya shabab, we have to, okay, to be careful in general, okay, that the light, as it travels from fast medium, you can put your hand down if you please, Laith, from fast region to slow region, okay, always the angle of what? Of refraction, the slow medium, it's a smaller, okay? So this is what? I over R, so, okay, we can use the formula directly. Refractive index equal sine I over sine R. And this will be the refractive index of the slow medium, the slow region, okay? Right. But if they do the opposite, if they give us, okay, that the light travel from slow region to fast region, okay, like this. So what we are going to do, we say that, okay, this is the angle of incidence in this situation, which is smaller, obviously, smaller than the angle of what? Refraction. This is the angle of incidence. In this situation, and for the slow region, okay, because usually they put the fast region as air, okay, it will be equal sine R over sine what? I. We flip the equation. If you don't want to flip the equation, you can use this formula, the original formula that I told you before. Okay, the long one. Ni sine I equal Nr sine R. Ni is the refractive index for the first medium, whatever it is, air or the medium. If it's air, it will be 1. The medium, they will give to you or ask about it. Okay, sine I, the angle of incidence, equal Nr, the refractive index for the medium which the light refract through. Okay, sine R. Now, as you can see, we have 4 variables, Ni, Nr, sine I, sine R, or I and R. They give you everything except one of them. They give you everything except one of them, and they ask about this one. Okay? Tamam? So that's why I prefer this formula. Ni sine I equal Nr sine R. Okay? Tamam? Yes, تفضل.
Why are both of them slow? Like in the
Now one of them it's supposed to be faster and the other is supposed to be slow compared to each other. If they are talking about the same media, okay, for both of them, that means the light doesn't change. Yeah, for example, a glass with the same optical density or same refractive index, that means the light doesn't change its direction. It keep moving straight line. And they bring this question a couple of years ago. Tamam? Any question? Okay. A very important thing that they always bring questions about it in the external is something called critical angle, or something else called total internal reflection. It's this actually. It's this about the same topic, the refraction of light. Okay, and they usually bring one of them or both of them in the same question. To understand the critical angle and total internal reflection, what do we have to imagine? We have to imagine a surface of water of a swimming pool. Okay, so we have water here. and there's air, of course, above it. And usually in any swimming pool, they put a torch or light bulbs and where inside the swimming pool for decoration and for seeing if there's something fall down or la samahullah, as anyone think. Okay, so the light always, a light source produce light in all directions. Okay, so if we took these 4 rays on our examples, okay, let's see each one by itself separately. Okay, the first ray, as you can see, it reached the surface perpendicularly. It reached the surface how much? Perpendicular. So how much is the angle of incidence in this surface when the light travel from water to air? How much the angle of incidence in this situation? Here. Yes, send me the answer. Yes, correct, huh? Who can give me another answer? No, it's not 90. This, don't forget, this is the normal. So how much is the incident angle? How much?
60.
How much? It's 0. Why 0? Now, this is the surface, this is the normal, and this is the ray. How much the angle between the ray and the normal? It's 0 degrees. So does the light refract? No, it does not change its direction, but it refracts. Why does it refract? Because it becomes what? It doesn't change its direction, but the speed becomes what? Faster in air, and also the wavelength becomes what? Longer. Okay, but its direction doesn't change because the angle of incidence in this situation was 0, and sine 0 is 0. Okay, sine 0 is 0, so that means sine I is 0, so sine R is 0 also. Here in this, here in the second situation, if this is the normal, okay, like this, and this is the angle of incidence. As you can see, this angle of incidence is a small. Okay, so what happened to the light as it traveled to the fast region in air? What happened to it? Bends away or towards the normal? What happens to it? Yes, exactly, it bends. It's supposed to continue like this. So does it get closer or away? Exactly, away. It bends away from the normal because it goes to the fast region in the air. So the angle of refraction becomes what? Greater, right? So as the angle of incidence increases more than 0, what happens to the angle of refraction? Keep increasing until what? Until it reach a certain value. Okay, and this value, now we will call it here in this situation. How much is the angle of refraction in this situation when the light reach the surface parallel to the surface? How much is the angle of refraction in this situation? How much? Exactly, how much? Bravo, 90 degrees. Why 90 degrees? Why the angle of height? Because, as I told you, as we increase the angle of incidence in the slow region, in the water, in the fast region, the angle of what refraction becomes more and more, bends away from the normal, more than the angle of what? Of incidence here. So what happened eventually? The angle of refraction, when the light refract parallel to the surface or in the same side of the surface, it will be what? 90 degrees. Now let's return back here in the beginning. Okay, we know that when you put yourself in front of a window of a car, okay, you can see yourself and you can see what's in front of the car, right? So that means some of the light refract, and some of the light what? Refract in this direction. As the light refract, there is light reflect. Also here, whenever the angle is bigger, some of the light refract into the medium, some of the light what? Refract out of the medium. Okay, angle of incidence equal angle of reflection. Okay, here as some of the light refract through the medium, some of the light will what? Reflect. Okay, but as I increase the angle more than I, here in this situation, what will happen? No light will get out here. Here there is no light get out. That means this angle of incidence, okay, in the slow region, the water, okay, it has a special name. We call it what? Critical what? Angle. C, critical angle. So what do we use critical angle for? Critical angle is the angle of incidence in the slow medium, in the water, in the glass, in the diamond, okay? That makes an angle of refraction in the fast medium, usually in air, which is equal to how much? 90 degrees. Why we call it critical? Because as the light incident is with an angle more than the critical angle, here this angle of incidence is greater than the critical angle for this medium, for this water, what happens to the light? It will not refract at all. It only reflects completely. No energy is what is refract. No energy is absorbed like in the first 1, 2, 3 situations. Okay, all the energy, all the light of it completely what reflect back, and that's called total internal what reflection. Now, how do they bring questions about this? They give you a picture, they give you questions, they ask you to calculate, they ask you to explain, they ask you to what define, and maybe they ask about some uses of total internal reflection, like something called endoscope that they use it in surgery to see what's inside the object, okay? Or they can use it in optical fibers in communication, fiber wires, okay? To send internet communication or informations, okay, or data in speed of light, no electricity, okay? So what do we have to do in this topic? We have a lot of things. Every year they bring a question about it, and every year most of the time they keep repeating the same ideas. But now in the last 3-4 years, okay, I'm talking about 10 exams, there was new ideas every time, okay? But it's still easy. It's still obvious if you understand it, okay? So first of all, we have to define what's the meaning of what? Of the critical angle. Who can tell me what's the critical angle? Look here, take a screenshot or a picture for this, if you please. Tamam. And right here, no refraction. Here, no refraction. Okay, tamam. So if I want to define critical angle, send me the definition that you want to write it down, okay? And think about this picture, okay? I'm trying to use it to explain what's the critical angle. Now I have two medium, okay? Two media. For example, diamond or glass or slow medium. And the light travel to a fast region or fast medium like what? Air or vacuum. This is the angle of incidence here in this here. This is the angle of incidence, okay? I will call it critical angle. That makes an angle of refraction equal how much? Equal angle of refraction equal 90 degrees where? In the fast region. Some of the answers, the angle between the normal and the ray. Okay, of course. What do you mean by the normal and the ray? Incident angle or incident ray? That means we are talking, if you are talking about incident ray, that means we are talking about something called incident angle. But the question didn't ask about normal incident angle. They asked about specific angle of incidence, which we call what? Critical angle. So what we are going to write, the definition of it, is the angle of incident through optically denser medium, optically denser medium, which causes angle of refraction, equal 90 degrees through the fast region. The fast region or the faster medium. تمام. Good. Write these down and label here on the picture this angle of critical called the incident angle, and the angle of refraction in front of it is supposed to be 90 degrees. Okay, in the fast region, like usually it's air or vacuum. The slow medium, maybe glass, maybe water, maybe diamond. It depends on the question. Good. So here we start to explain something called critical angle and something called total interreflection. Now we are going to define the total interreflection and we are going to answer a question about both of them. But before we continue, let's go back here. Okay. So we know that Ni sine I is equal to what? Nr sine R, right? When we talk about critical angle, the other angle is supposed to be how much? Yes, supposed to be how much? We're supposed to be equal how much? 90 degrees. When we talk about critical angle, the other angle in front of it is supposed to be 90 degrees. And how much is sine 90 degrees? How much is sine 90 degrees? How much? Sine 90. Exactly, it's 1. Yes, shukran. Shukran. Tamam. So Ni, for example, the medium that we are talking about, for example, N medium, M, equal sine, I'm sorry. N for the medium, for example, glass or whatever it is, N medium, okay, or glass, sine what? The critical angle, C, okay, equal Nr, usually air, okay, Na, air, sine how much? Sine what? 90. And we know that Na for air is 1. And sine 90 also, it's how much? It's 1. So N for the medium, we use the letter N or N, doesn't matter, and M, okay? Sine critical angle is equal 1 times 1. How much is 1 times 1? It's 1. So divide by N, divide by N, okay? So C, the critical angle that we want to find out, equal sine inverse for how much? For 1 over N. Some of the people, okay, they memorize this formula. Some of them, they know how to drive it, how to reach it. So this is about, we can use it by long formula or by short formula, okay? In the short formula, we talk about the refractive index from where to where? From slow medium to fast medium. We are talking about this refractive index for glass, G, okay? So that means I flip the equation, sine R over sine I, and the R is 90 and I is the critical, okay? Whenever they are talking about critical angle, the opposite formula or the other formula in front of it is what? 90 degrees, and sine 90 is 1. So we can say that the refractive index equal 1 over sine the critical angle, or we can say critical angle equals sine inverse 1 over the refractive index. So you can use one of these formulas to memorize it, or you know how to drive this formula, how to reach this formula. If they ask or if they give us critical angle, okay? تمام? كيف بيجي السؤال? Okay, hold on. I'll show you how the questions they bring it, okay? Good so far? طيب, yeah, let's move on. What is the definition of the total interreflection? The definition of critical angle, it's included in the syllabus, and the definition of what total interreflection and the uses of total interreflection also it's included in what? In the syllabus. So how can I define the total interreflection? What is the definition of total interreflection? Look here, ya shabab. Some of the light refract out in the air, some of the light reflect back to the water. Some of the light refract, some of the light reflect, and some of them absorb. Some of the light refract, reflect, okay? But in this situation, when the angle of incidence exceeds, is more than, greater than the critical angle, there is no refraction. There is no absorption, only what? Reflection completely back. So if I want to write the definition here, the case when the incident ray reaches, or incident reaches the surface of optically denser medium, optically denser medium with an angle of incidence, I'm sorry, with an angle of incidence yes, thank you, greater than the critical angle. Greater than the critical angle. What will happen here? Bravo. What will happen? Huh? Another answer. All the light. What will happen to it? All the light exactly reflects back completely. All the light reflects back completely. All the light reflects back completely. And where we can see this, we can see this in something called endoscope. Okay, we are going to talk about it later on, endoscope, or we can see that in communication optical fiber. Okay, optical fiber wires that they use it for the internet now, optical fiber. Okay, any questions so far? Any question? Okay, tamam, write these down. Now, question number 4. Here in this question, what they said, what they give us. They said that, question number 4, a ray of light reflects from a fish up towards the surface of a pond at an angle of what, 20 degrees to the horizontal. This angle is what? 20 what degrees. The light reflects back from the fish to what? To the surface between water and what? And air. And they have to give us something that I didn't mention it here. They have to give us that how much is the refractive index of the water, which is approximately 1.33. Okay, don't memorize this value, but approximately 1.3. Okay. What they ask in part A, what is the critical angle of the ray travel from water into air? Now, we say that critical angle equal what? Sine inverse for what? 1 over the refractive index for the medium that causes the refraction. Okay, that causes the critical, that causes the total interreflection, which is the water. So by using calculator, sine inverse for 1 over 1.33, and by using calculator, how much is the answer? Sine inverse of 1 divided by 1.33, and the answer will be how much? 48.753. So you are going to write 49 what degrees. Okay, so this is the critical angle for water as the light travel from where? From water to air. This is the critical angle, 49 degrees or 48.8. Okay, right. Now my question, how much is the incident angle here in this situation for this ray? How much is the angle of incident in this situation? Yeah, send me. Oh, no, check if you please. No, we have 2, 3, 4 not correct answers. Again, the angle of incident is the angle between the incident ray and the normal. Yes, we get correct answer now. Another correct answer. How much is the answer? Exactly. Shukran, bravo. Shukran ya Layth. Shukran ya Muhammad. Exactly. This is the angle of incidence. And how much is the angle of incidence in this situation? Because this is normal. This is the surface, 90 degrees minus 20. It will be how much? 70 what? 70 degrees. So that means, ya Shabab, what will happen to this ray, okay, of light in this question? What will happen to this ray? Because the angle of incidence is 70 more than the critical angle. What will happen in this situation? Yes. Bravo. Exactly. It will what? Yalla, I'm waiting for other answers. Bravo. It will reflect back What type of reflection is this called? Bravo, total internal reflection. You can say TIR. You can say TIR. Total internal what? Reflection. TIR. Now, some of you will ask me, did they ask why this happened? No, they didn't ask. But if they ask, what you are going to say, because the angle of incidence is greater than how much? Greater than the critical angle, because 70 degrees is more than 49 degrees. That's why the light reflects total internal reflection. Good? Obvious? Tamam? If you please take a screenshot for this question here. Question number 4. Now, let's move on. We have multiple choice questions. As usual, these multiple choice questions, they are your homework for next time. Okay. Let's move on to question number 1, page 54. Question number 1, page 54. Yeah, together. Okay. What they ask in this question. The figure below shows a section. Okay, this is a core question. Okay. This is core. Do they bring similar to this one? Yes, but a little bit harder. Now, but maybe same idea, even same numbers, okay? In the extended, yes. This is in page 54. Okay, page 54. Okay. So what they ask? The figure below, okay, shows a section through a swimming pool in a hotel, okay? To make the pool, okay, more attractive at night, there are submerged lamps in the pool, okay? The figure below shows 3 rays coming out, okay, coming from one of these lamps, okay? We have 3 lamps. This lamp that show us that it refract and reflect. Lamp goes towards point A, another light ray, sorry, goes towards what? B. So we have 3 rays. 1 to the left up and 2 to the right up, 1 to point A and 1 to point B. Okay, the critical angle. Yes, Muhammad, فضل.
Sir, how can the ray reflect back and go to the air at the same time?
Some partially refract, partially reflect. If you stand in front of the window of any class, you can see your reflection and you can see what's inside the car. Some of the light refract, some of the light reflect. That's why we said completely reflect when we talk about total internal reflection. Okay?
Okay, thank you.
Good, good.
Yeah.
Okay. The critical angle of the water-air boundary is how much? 48 degrees. State, that means they ask about what's your answer, so it's something that you know it. State what is meant by the critical angle for ray of light. Huh? What's the meaning of critical angle here? Is the angle of what? Huh? Is, yes, write the answer. Is the angle of incidence. Yes, bravo. Is the angle of incident where? Through water, bravo. Through water. In this question, through water or through the optical denser medium. Through water, okay, which has what? Has angle of what? Exactly, angle of refraction, bravo. Angle of refraction equal how much? In air. In air. How much is the angle of refraction in air? No, be careful, Muhammad. How much is the angle of refraction in air? Equal 90 degrees. Equal 90 degrees. Okay? Tamam? They don't put 3 marks on the definition, they put 1 or 2 marks. Okay, but because this is a core paper, they put 3 marks. Tamam? Then what do they ask here? On the same previous figure, use your ruler and draw the approximate path for the rays, okay, after they reach the surface at point A and at point B. Look here, يا شباب, شو بدي أعمل? I'm going to use this software, okay, that has a compass, protractor, ruler, okay. Look here what I'm going to do. Now, first question, what they ask to draw what will happen to the light as it reach the point A. Now, what do we know? We know that some of the light will refract, some of the light will what? Will reflect. How much is the angle of incident at the surface A? How much is the angle of incident at the surface at point A? Exactly, it's 40 degrees, bravo. So what we will do, we'll make the angle of how much also 40 degrees to the normal. This is the normal, 10, 20, 30, 40. And then what we will do, we will draw the what? The reflected what? Ray. That's partially reflected, okay? And also in part B, the angle of incidence is 50. Also, I will draw it that reflect with an angle of what? Reflection also of 50. Okay, let me try to fix it. Okay, something like this. So what we did here, we draw the angle, the reflected ray from point A. We draw the reflected ray by ray B. Okay, and the angle here is supposed to be 40, and the angle here supposed to be what? 50 exactly. But what did I miss here? What did I miss? Bravo. Yes, I missed that. Here, 40 degrees is less than the what? The critical angle. 40 degrees is less than the critical angle. So what I can do here, I can draw some of the light that refract out, okay, in the air. I can draw this, yes, but that will not happen for this one in ray B. Why? Why it cannot happen? Because the angle of incidence 50 is more than what? 48. So it's only what? Exactly, it's only what reflect back. Let me repeat this. خلينا نعيد مرة ثانية. Now what do we have here? What do we have here? We have a ray that incident at point A at 40 degrees. And 40 is less than how much? 48. So some of the light will reflect, okay, with an angle of 40, and some of the light will refract away from the normal, of course, away from the normal because it's in the air, it will be faster, okay? So what we will do, how we can do it, we are going to bring our what? Our protractor, put it on exactly on the point A. This is the normal. I'll measure the angle of how much? Of 40 what? 40 degrees. Yes. Then what? I will draw the reflected ray from the point A, okay? This is what my angle of, this is the incident what? Ray. And also, this is the reflected ray. Tamam? And also, this is from point A. And also I will draw what? The refracted from A, and it will be away from the normal, something like this, okay? But for B, because the angle of incidence is 50 degrees, and 50 is more than how much? 48. So it's the incident angle is greater than the critical angle. So what happened to the light in this situation? It will refract total internal reflection. So I put my protractor, okay. طبعا ترقص هذا. I can't fix it. خليني أشيل هذا الضوء. Okay. I put it here and what? On the point B, and I'll measure angle of how much to the normal, of how much? 50 degrees. This is the normal here. Okay, it's supposed to be 50 degrees. Then I will draw what? The reflected what ray from the point B, like this. This is what? The reflected ray. Okay, and this is also here. I can draw, that's the refracted ray from the point what? From the point A, yes. Is it clear? Is it clear? Any question here? Any question? Okay, fine. Take a screenshot if you please. This is the answer here. And you can see that this angle is 30 and this angle is more than 30. They give you a hint what you are going to do here. طيب, يلا. Let's return back to the question. So we did these 7 marks core paper. Tamam, let's go on to see extended papers like this one. This is extended paper. Okay. What do they ask here? Bismillah. Question 2. In the following figure, a ray of light TRC, TRS. As you can see, it enters the block here, the glass block here at this point perpendicularly. Okay, so it doesn't change its direction. We are going to explain it later why. Okay, I just say the answer. Okay, then it reached the point R, okay, and move away from what? Okay, later we'll talk about you later, hold on. Okay, then it moves to the point S. Okay, tamam. What they ask in part A, as the light enters the block, frequency remains constant. They tell us the frequency remains constant because we know according to the 6 S's, frequency is same. Okay, state what will happen to the speed, to the wavelength as it enters the glass block. And we know that the glass block is slower or faster region for light. Exactly, slower regions like shallow water. So what happened to the speed? It will be slower. Bravo. Exactly. What happened to the wavelength? It will be shukran ya Muhammad. Aywa. It will be what?
Shorter.
Exactly. It will be shorter. The wavelength will be shorter. Okay. So this is easy 2 marks. Okay. Next. B. The refractive index of the glass in this situation for this question is 1.48. Okay. The speed of light in air is 300 million meters per second. Calculate the speed of light in the glass. State the equation that you will use. What's the equation that we are going to use it? What's the equation that link the refractive index with the speed? To parler français, what is the equation that we are going to say it in French?
C over
Exactly, refractive
V.
index equals C over V. C'est la V. Okay, they ask about V. So V equal what? C over N. Good? C over N. Bravo, ya Layth. So C, which is 3 times 10 to the power of 8, divided by N, which is 1.48. And by using calculator, the answer approximately 2.08 or 2.02. Yes, 2.03 times 10 to the power of 8 meters per what? Meters per second. Tamam? Next. Another ray of light enters the block along UR. Okay, this is UR. Okay, on the same previous figure, draw line to show what happened to this ray after it reached R. Who can tell me UR? This ray from U inside the glass block reaches R. What happened to this ray? Does it refract? Does it refract? Yes or no? Does it refract? No, it doesn't. Yes, bravo. Doesn't refract. Why it doesn't refract? Because look to the angle of incidence. It's a huge angle of incidence. Yes, it's big. So what happened to this light? It's only what? Bravo. What's that called? What's that called? It's only reflect back. Bravo. What's that called? Exactly. It's called TIR, total interreflection. So I will use my ruler and draw a ray that's travel in this direction, like this. Okay, with the same angle, I will use my protractor and a ruler, and I have to make sure that these angles are equal. Do you want me to draw it with a? Okay, I'll draw it. Okay, look here. Yes, we are going to bring our protractor. We will flip it upside down. Okay, we'll put it up. Sorry. We'll bring it until here. We can measure that this angle is how much? How much is this angle from here to here? Exactly. Bravo. The angle is starting from 90, 10, 20, 30, 40, 50, 60, 70. 70 what? Approximately 77. I will make the same thing on the other side, 77. Bravo. So it will be starting from 90, 10, 20, 30, 40, 50, 60, 70, 77 until this position. So I'll put my this one here, and I put it here approximately, yes, and I draw, yes, the reflected ray like this. Tamam? All of this by ruler. I'll mark a point here and I'll draw it. Good, and don't forget to put an arrow. Tamam? You can take a screenshot here if you want. Okay, good. Let's move back to the paper and to the questions. I want from you to try to do this question as a homework also, question number 3. It's a homework. Okay. And I'm going to start talking about the last thing about refraction, which is called dispersion. Now, dispersion, since we are in the winter now, who can tell me why it's important dispersion in the winter? Because after the rain, sometimes we can see what?
Fog.
After the rain and there's sunlight, okay, we can see
Rainbow.
we can see the rainbow.
Sorry.
Exactly. So dispersion means that the light that comes from the sun, it's not one color. It's mix of several colors. It's not one color. It is mixed by several colors, and that's why they call it what? Pterochromatic, not monochromatic. Monochromatic means a light of mono in Latin, or ono in italic, Italian language, means one color. So monochromatic means the light of what? Page 57. Yes, in dispersion, page 57. Okay. Monochromatic means light of single color, but white light is not that light that comes from the filament lamp or the light that comes from the sun. It's not one color. It's several colors. That's called rainbow colors. How many colors there are in rainbow color?
Rojbif.
Rojbif, I told you that. How many colors? Exactly. They are what?
I think there are 7.
They are 7. Red. After red.
Orange.
Orange.
Green.
Yellow. Roy. Yellow. Green. Blue. Indigo.
Yes, and violet.
Okay, we have to know this in order. Okay, so the dispersion is the spreading out, or the separation of the white light to its 7 colors components, making rainbow. Making what? Rainbow. Okay, so now, as we know, in the last 2 decades, we have a very famous competition in football, okay, between 2 amazing legends in football. One was playing in Real Madrid and the other was in Barcelona. Now both of them, they are in
Cristiano and Messi.
Manchester United and Paris Saint-Germain.
Yes.
They are exactly. Now, actually, both of them, they are very fast. They are too fast compared to us, okay? So when both they run as fast as they can, and they are very fast, approximately the same. But which one can refract or deviate or change its direction faster? The taller one, or the shorter one?
I think the shorter
one. And the shorter one wears what's the color of yes, exactly. What's the color for
violet?
Or exactly, or Paris Saint-Germain? It's blue or violet. Okay, but the other hand, Manchester United, the long one, the long wavelength, the long step for Cristiano Ronaldo is what? Is red. So if I'm talking about Cristiano Ronaldo and Messi here, okay, now look what I'm going to do here. I'm going to compare between both of them, okay, as colors, okay, and because I'm talking about colors here, I have to be careful about the order of these colors. Now, it's very important for us to know that the red color, okay, which is which is Cristiano Ronaldo, okay, because since it's long wavelength, long step, okay, he's long, not short as Messi. He has Cristiano Ronaldo. He has low frequency of number of steps, but not like Messi, a high frequency of number of steps. So he changes direction, bend towards the normal a little bit, like this. That's Cristiano Ronaldo, the red. Then again, we get out from where? From what? From the other surface of the glass prism, glass block, okay, to be somewhere here, okay? That's Cristiano Ronaldo, the red one color. On the other hand, Messi, he will deviate from the beginning when it enters the glass block. He will deviate with with different bigger angle, okay, not that much big, okay, a little bit, okay, then deviates more away from what? From the surface like this. And we can see that this color, it will be the red, and this color will be the violet, and between them, it will be the rouge vif that I told you about: red, orange, yellow, green, blue, indigo, what? Violet. So, and above this, it's infrared, and below this, it's what? Ultraviolet. So that's how the colors, they change their direction, they deviate. That's why I said about Cristiano and about Messi. Messi has higher frequency, so he changes direction more than what Cristiano Ronaldo, that has lower frequency since he's long, okay, he's tall. Tamam? If you please take a screenshot for this drawing, and I want from you to understand how to and memorize the compare between Messi and Cristiano Ronaldo, okay? Tamam? Good? Okay, now how do they bring questions? A lot of ideas they bring it in the last 3 years, okay, about red and blue or violet, okay, and how they change their direction when they travel from medium to another. Okay, a smart question before we continue, a smart question. Which one has greater critical angle? The red or the violet? I'm not going to answer the question now, okay? You will think about it, and we are going to answer it later on, next time, okay? Tamam? Let's go back. So we have to know that, I'm going to write this down here, okay? Red has less what? Refraction as entering, as it enters the prism, while violet refracts more. Refracts more. Tamam? Good. So in this question here, question number 1, which is the correct choice? A or B or C or D? Which one is the correct answer? Which diagram correctly shows the path taken by the red and by the blue as they enter the white light? Look, I'm talking about white light, not monochromatic. I'm talking about, yes, all the rainbow colors. Exactly. شكرا سيدرا, شكرا ليث, شكرا محمد, شكرا للشباب اللي عم بيجاوبوا. The correct answer is D. Bravo. Excellent. That's it for today. الله يعطيكم العافية. بدي اياكم ترجعوا تدرسوا هذول المواضيع. I want from you to re-study these things again. Okay. So it will be easier next time when we start talking about this. If you have any question, you can stay online. If you don't have any question, you can leave. Have a nice day. Assalamu alaikum wa rahmatullahi wa barakatuh.